Hello. All right, well, the slides come up. I'm here to talk about some fieldwork we did at a lunar analog in Utah. This work was funded by an SSW, and we also had some friends come along from the LunarVice team, and then also someone, Peter James from Baylor University, who was using an early career award. Okay, so the origin of silicic magmas remains a key outstanding question in lunar science. So most lunar volcanism was basaltic, but Apollo samples, such as the ones shown on the slide, and silicic hotspots identified from orbital data indicate that there are more evolved magmas on the moon. And so the question remains, how did silicic magma evolve on a planetary body without plate tectonics? And so there's a couple ideas, crustal melting, silicate liquid immiscibility, that could answer this question. And fortunately, planned future lunar exploration is going to be able to address questions like this one about lunar silicic volcanism. Hopefully you saw Carrie's talk earlier this week about the LunarVice mission. It is a PRISM 2 payload that's scheduled to land at the Gruithuisen domes in 2028. And Firefly and Honeybee were recently selected to be the lander rover provider for us. And so we're very excited by that. So briefly, the LunarVice science goal is to understand how late-stage lunar silicic volcanism works under lunar conditions as typified by the Gruithuisen domes. This shows the Gruithuisen domes. The star is the landing site for the CP-21 lander, and the LunarVice payload includes visible cameras, thermal cameras, and a gamma-ray neutron spectrometer. And so what we're trying to do with this project is to better interpret data from missions like LunarVice that are investigating silicic lava domes on the surface of the moon. And so what our project goals are is to help us answer these questions. And so the first question, how was silicic magma generated on the moon? Our project goal is to evaluate petrogenic models for generating silicic magma at an analog site in order to improve constraints on lunar volcanism. And then another question we want to address is how can lander scale surface characteristics at lunar silicic volcanic deposits be tied to eruption parameters? So how did the lava actually get to the surface? And so we're going to do that by linking volcanic eruption styles to geomorphology and thermophysical properties, which are things that we can observe with a payload like LunarVice. And so generally, the goal is to maximize the science return of future lunar missions by using relevant instruments at an analog site. So our analog site is the Wildcat Hills in Utah. This location is compositionally, tectonically, and morphologically analogous to lunar silicic domes. So there are two domes. One is dacitic and one is rhyolitic. They're located in an extensional valley. They have a debated magma origin, and so there's kind of some evidence that maybe it's crustal melting, there's some evidence maybe it's SLI, and so it's a good place to go and kind of test these hypotheses. And then finally, these are older domes, they're about 2 million years, older for Earth, and so the soil and vegetation cover on the domes mutes the topography and simulates regolith cover. So instead of there being a brand new pristine lava dome, we're kind of looking at isolated outcrops to simulate looking at like a boulder here or a crater wall there on the moon. And so we made it out into the field just a couple weeks ago, and so I don't have all the results yet, but I am happy to tell you what we did, and so that you can look for results in the future. And so you can see from these images what I'm talking about by there's lots of vegetation and soil cover. And so we have to kind of like bounce from this outcrop to that outcrop to kind of see what's going on. And so we had a couple different field teams. And so the first team we had was the sample team, and this had two purposes. It's collecting samples for petrologic and spectral analysis. So for the petrology side, the goal, as I've said before, is to investigate the origin of both of these domes in order to provide modeling constraints for lunar silicic domes. And then on the spectral analysis side, the goal is to conduct near-infrared and thermal infrared spectral analysis of the Wildcat Hill samples so that we have a variety variety of compositions and a variety of volcanic kind of features and textures for reference for Lunar Vice. And I hope that you saw Taylor Barica's poster last night that presented the preliminary results from that part of the study. And then the next up is thermophysics. We had a drone-mounted thermal camera, and so they took photos throughout the day to enable thermal inertia calculations for key locations on each dome. And so the goal of this is to characterize the thermophysical properties of the different dome compositions, different flow features, so that they can have a foundation for interpreting thermal inertia data from Lunar Vice. We also had the gamma ray and neutron spectrometer team from the Lunar Vice team come out, and so it was exciting. They had a cart-mounted GRNS, and they did some field tests to develop concept of operations for the GRNS on Lunar Vice, and then they also have these field measurements that we'll be able to compare to the sample data. There was also a geomorphology team, and so geomorphology and textural analysis will enable reconstruction of the lava dome eruption history, and cataloging features and textures at an outcrop scale specifically will enable consideration of how these features might appear differently on the moon, and if we observe them on the moon, what would that mean about the eruption? And so I'm excited to dig more into that as well. And we also had a friend come with a gravimeter, Peter James, and so they were able to range across all of the domes to get measurements, gravity measurements, to look at the porosity and density of the domes. And this is super helpful because, as you can see, they can look at anywhere, even if it's covered with vegetation. And so it's a really nice complement to the other data. And this is my final slide. I have no idea how much time I actually have because of the delay, but I will leave off by saying that any of these individual slides could have been its own talk, and they will be their own talk, so definitely look out for results from the team in the future. And so we're very excited to do this field work at a lunar analog in order to prepare for future exploration at lunar silicic domes, because there's missions that are happening, and so we're excited to prepare for that. Thank you.